Okay, so this problem says 1.28 kg sample of water at 10 degrees Celsius is in a calorimeter. You drop a piece of steel with a mass of 0.385 kg at 215 degrees Celsius into it. After the sizzling subsides, what is the final temperature, equilibrium temperature? Make the reasonable assumption that steam produce condensation into liquid water during the process of equilibrium and that the evaporation and condensation don't affect the outcome, as we'll see in the next section. Alright, so what you have is a calorimeter, and it's got 1.28 kg of water at 10 degrees Celsius, and then what you do is you drop a steel object in there, and that was initially at 215 degrees Celsius, 0.385 kg. And what is the specific heat of steel?
Calories or joules?
Joules.
452.
Okay. All right, so what happens is when you drop the steel, heat flows from the steel to water. So the steel object loses heat and water gains heat. In calorimetry, what you assume is you don't have any heat loss and so on. That's what this device is supposed to do. And the calorimeter itself is not absorbing any heat, or its mass is very negligible. It's a very light object, so and the heat absorbed by the calorimeter is negligible. Okay. All right, so heat lost by steel plus heat gained by water equal to 0. So if the steel loses 50 joules of heat, the water gains 50 joules of heat. Okay, that's the deal. So heat lost, it's steel, mass of steel, specific heat of steel, and change in temperature of steel, plus heat gained by water, specific heat of water, times change in temperature of water, equal to 0. So we'll put in all the values. So, well, ms actually cs, T final minus initial temperature of steel is 215 degrees Celsius, mass of water, specific heat of water, and T final is the same. The final temperature is the same for water and steel, minus 10 degrees Celsius. Okay, so the final temperature will be less than that, so this will be negative, and the final temperature will be greater than that, so this number will be positive. And of course, what we know is if this number is minus 100, that number will be plus 100, and that'll be equal to 0. Okay, the reason I wrote it like this is what we're solving for is TF. So and we'll bring these terms to the right. Okay, so okay, so the final temperature is MSCS 215 degrees Celsius plus MWCW 10 degrees Celsius divided by MSCS plus MWCW. All right, so now we can put in the values. Okay, maybe I'll use another page. Okay, so all the units will cancel and you'll get the final temperature in Celsius. Okay, so let's do this. 16.4 degrees Celsius. Okay, as promised, this temperature is higher than 10 degrees Celsius and lower than 215. And the thing to notice is, see, so the final temperature of the water and the steel is 16.4 degrees Celsius. The steel object dropped from 215 to 16 degrees Celsius. And the water temperature rose only from 10 to 16 degrees. So the water's temperature rose by 6 degrees and the steel's temperature dropped by 200 degrees. Why is that? Yeah, so the heat capacity for water is almost 10 times the heat capacity for a steel, and that was the difference. And so the temperature difference was about 10 by a factor of 10. It would have been exactly 10 if the masses were the same. The masses were slightly different too. All right.